Okay, so today we're going to talk about the processing of data on a biometric system. So this is to assist software developers in integrating biometric algorithms into their own database. So every biometric hardware is for all intents and purposes a camera. So what it's doing is taking in most cases a raw image of your fingerprint or your face or your iris, and what it's doing is converting that into a binary string representation of that image and then storing that in a database. So let's just have a look at what that means for a software developer. So the SDK with the hardware drivers will allow you to connect to the hardware, and essentially there should be an image capture element in the SDK that allows you to capture the image from the camera, which is essentially the fingerprint sensor in this case. What the algorithm then tries to do is it will have a pattern matching approach, so it will identify some points on the image and it will create a mathematical representation of them. It essentially uses an equivalent of a hash value to create the template, which means that there's a good deal of security in a biometric template, in that it's very difficult to go back to the original image, if not impossible. Most of the information about the image is discarded and some key points on it. Obviously, depending on the quality of the algorithm depends on the approach and technique here. Some of them are very proprietary, and the top algorithm in the world, like neurotechnology that we use, has a very advanced system of capturing the amount of data and converting it into a template. In most cases, it's better to use the proprietary template provided by the manufacturer than the ANSI standard. So essentially these open standards are the lowest common denominator in terms of image capture and processing, and as such you lose some quality in doing that. But the advantage, of course, is the interoperability then between all the different systems. So if you're working with neurotechnology, it's best to use their internal proprietary approach to this. So once you capture an image, you can of course store the image in your own database alongside the user profile in the usual manner, because of Data Protection Act and GDPR, we recommend you encrypt the image to meet the current compliance standards. Once the algorithm has created the hash version of the template, essentially it's a binary string, so you can store this binary string representation of the image in something like an nvarchar on the database, and then once it's on the database you'll have an image and a binary string field, and then you can synchronize those data around your database estate. So if it's on a mobile device, you can sync it up to a central database and back down again if you need to later. When biometric systems process data, what they'll do is load this template information into memory, and all the searching for users normally occurs in memory. This is simply for speed, because obviously one of the things a biometric system has to do, as opposed to other smart card and other type systems, is we must search the entire database. There's no way to index template or binary string information. You must search the entire database, and as such this is quite a memory intensive and processor intensive process, and therefore we recommend at a later stage you look at database segmentation and other advanced database techniques that can help you speed up this process. So once you have captured the image and turned it into a template, then in terms of database processing, you simply have an image and you have a binary string array of data. If you have fingerprint data, you may have 10 fingers, 1 face, 2 irises, and so on. Once it's in the database, then the usual database rules apply. You can back up the data, you can sync it, you can restore it, and so on, to give you the interoperability and the mobility of the data from there on in. So it's pretty straightforward.